Hey, I'm Sanjana with the Arize team. Today I'm going to be doing a walkthrough on trace level evaluations. This walkthrough is going to focus on how to do these kind of evals in code. I'll be back shortly with another video on how to do this within the Arize platform itself. But today we'll be, running all of our evals using Phoenix evals in code. We'll log those results back to Arize, and at the end I'll show you what trace level evaluations look like within the platform itself. So just as a refresher, what's a trace? When you make a call to your LLM application, it tends to take a series of different steps, operations, all sorts of things to get you back your final answer. A trace represents all those different steps that your application took. At a more granular level, a trace is made up of spans. So that's kind of what we can see in this picture over here. This trace has, multiple different tool calls happening. It has some LLM calls as well. Other kinds of spans can be like retrieval, for example. All sorts of different operations can happen within your LLM application itself, and each one of those operations is represented in a span. So this is how it's going to look visually. Another option to look at this is your trace will have an ID attached to it, and then each span will also have an ID attached to it with all sorts of data, so input, outputs, metadata, all of that. So typically when we talk about evaluations, we're talking about evals at the span level. So did my LLM hallucinate? Was the answer toxic? Did my tool call use the right parameters? Was the tool accurate? Those sorts of evaluations tell us on a more granular level how our application is performing. But when we take a step back and do trace level evaluations, we get really great insight into whether or not the overall task was successful, because we're looking at every single span holistically rather than looking at the evaluation at each step. So at that point, we can begin to answer questions like, was the overall request accurate, successful, efficient? And that gives us a more end-to-end perspective in our evaluation. This is really useful for multi-step workflows. For example, say you have a RAG pipeline, you have a multi-agent system. When you do evaluations at the trace level in those cases, you can look at the entire performance, all the different agent calls, tool calls that happened, and you can get a final answer if all of those in conjunction were successful, were accurate, performed the way you intended it to. I find this to be a really powerful way to do evaluations. Today we're going to be doing an example on how to do this with a movie recommendation agent that I built. So this is a pretty straightforward agent for some sort of recommendation system. You can customize this to be whatever you want. But I have my agent over here, and then it has 3 tools it can access, where I ask it to find movies, review movies, and write previews for movies. So as a user, I can, go to this agent and ask, hey, I want to watch a comedy movie. And I would expect my agent to go, find a couple of relevant movies, review them, write previews, and return a couple answers to me that have reviews, relevant movies, and previews all in one spot, so I can just quickly read and pick a movie. At the trace level, we can look at the different steps the agent took. Was it calling all the right tools in the right order, and was it doing that efficiently, and have a tool calling accuracy evaluation. And then we can also just look at the overall relevance. When I say I wanted a comedy movie, did I get an action movie back? When I say I want recent movies, was I getting movies from maybe 20, 30 years ago? These are all questions that, span level evaluations alone can't answer. We have to look at how the agent performed overall to get this kind of feedback. And from there, we get a better view of how the end-to-end process is performing. So with this diagram, with all of that theory out of the way, we're ready to start actually running this agent and running some evals on it, and we'll see how that goes. So now we're in the notebook. I already went ahead and did some setup for us. So that was bringing in the relevant libraries, brought in my Arize Space ID API key, and then the last setup step I did ahead of time was this configure tracing step over here. I'm going to be using OpenAI Agents and OpenAI to construct that agent I just showed. So with that, I need to bring in the relevant open inference packages. So that's over here. And then with that, setup is done, and we are ready to actually start building the agent. The first step that needs to be done is defining those tools that we talked about. So starting with the first tool, movie selector. If I'm the user and I ask, I want to watch an action movie tonight, we're going to pull out action as the genre and pass that in as the parameter to this tool. The prompt is saying list up to 5 popular streaming movies in the action genre, for example, and then only provide the movie title. So this is just selecting relevant movies. We use GPT-4 over here. We make an OpenAI call here, so that will also be traced nice and neatly. And what we return is a list of movies. The next tool we have to find is reviews. So it takes in a movie as a string or a list of movies as strings. And for each movie, it will give it a rating by looking up ratings on Rotten Tomatoes, for example, and then sorting the movies from highest to lowest ratings. And it also will provide a little explanation as to why it got that rating. We once again do this using GPT-4, And finally, our last tool is that preview summarizer, which takes in one movie at a time. And for each movie, it will write a 1 to 2 sentence summary describing the movie. So if I have a list of 5 movies that I get from Movie Selector, I pass in that list of 5 to reviews. I get a list of 5 reviews sorted from highest to lowest review. And then for each movie, we then do like 5 separate tool calls to preview summarizer. So from the user perspective, the final answer the agent will return is a list of 5 different movies, rated and sorted, and for each movie we will have a nice little preview attached to it. So in our ideal case for this kind of question, that's the kind of output we're going to get. So I'm going to go ahead and just like run this cell where we have all our definitions there. That's taken care of. And then the last step is actually defining our agent. So up here from OpenAI Agents, we imported agent, and that takes in a name. So I have movie recommendation agent. I listed all my tools over here. That's exactly what we defined up here. And I used this decorator in order to mark this as a function tool. And then finally, we need a system prompt for our agent. So instructions. All this is saying is, you're a helpful movie recommendation assistant. I have each tool listed with a description of what that tool does. And then the goal is saying we want to provide user-friendly responses with relevant information back to the user. And then we use this runner.run function to actually, pass in our agent and our user input, which is a question. So in this case, I'm going to say, which comedy movie should I watch? And let's run this. Okay, so this has now finished its run, and we can see our output is exactly what we expected. We have 5 different movies returned to us. We have a rating associated with it, and then we also have a quick summary. And if you notice, our movies are also sorted from the highest rating that it got to the lowest. And then at the end, we also get a little recommendation of like, I recommend Palm Springs, and that's the highest rated movie over here. Let's jump over to Arize and see how this agent trace looks like. So now we're in the Arize platform. We're under my project movie recommendation agent. We have one trace over here, which is that request that we just made. So if we click into it, we can see a lot happened. So if we start with this first LLM call over here, we have our instructions that we passed into the agent initially. So just your helpful movie recommendation assistant. We have our user query, and then we begin to do all those little tool calls that we were talking about. So if you see the spans with a yellow icon and that tool icon, those represent calls to our tool, and then nested under that is our LLM spans, because if you remember how we define the tools, we make calls to GPT-4. So in our first tool call, we have our movie selector. It accurately grabbed comedy as the genre, and it returned movies as strings, which is what we asked for. That's what our LLM call did for us. And then if we can keep going through this, the next step was passing it to the reviewer tool, and what we got returned was all our reviews in order with a description next to it, and that's what our LLM call did for us. And then if you recall, the preview summarizer takes in one movie at a time, which is why we have 5 different calls to that tool over here. And then at the very end, we get all of our different steps in order, and we see our final output, which is what we saw in the notebook. So that we know how one execution works, we have a sense of how this trace looks like. Let's run a bunch more of these so we can start running some evaluations. Let's go back to the notebook. So what I have down here are 6 more questions to call out a few. Which Batman movie should I watch? What is a very scary horror movie? Recommend a musical with great songs. So all things our agent can hopefully accurately and effectively answer. So I'm going to run all of these, and then we'll come back and continue from there. Okay, this has finished its run. We have now 7 different traces in Arize of this agent running. Let's start with evals now. The first thing to do is grab all of that span data from Arize and aggregate all of our spans into traces based on the trace ID. So first thing we need to do is define our Arize export client, and we do that using our Arize API key. That should be Arize over there. This should also be Arize. And we use export model to data frame in order to do this. So we pass in our model ID, which was our project name that we saw in the platform itself. And then we also specify a start and end time. I'm doing right now to 7 days ago, so that should be plenty of time to grab all that data I just ran. So if we run this, we see we exported 124 rows. So with all 7 questions, we had 124 spans total. And then the next step is to group all those spans by the trace ID, which is over here. What this code is doing is taking this data frame with all our spans, like I said, grouping by trace ID, and then we aggregate into attributes input value and attributes output value. The input value is going to be, the first input of the first span in the trace. So basically this is the question that the user asks. And then our output value has all the outputs from that trace. And if we run that, So we have our trace ID, and then we have our input values, and then we also have our output values. At this point, all of our data is formatted properly into traces, so we're ready to actually run the evaluations on our trace data frame. In this tutorial, we're going to be defining and running two different evaluators. Once I show you how you can, actually do this, you can go in and maybe add your own different evaluators for practice, or, understand how to customize these for your own use cases. So the first one we're going to be doing is tool calling order. And what that does is it takes in the user input, which is this column over here. And then it also takes in the full trace output, including the sequence of tool calls made by the agent, which is going to be this column over here. And that's going to be our user input, our trace output, and it's going to respond correct if all the tool calls occur in the proper order and fulfill the user's request logically, and incorrect if otherwise. And the second evaluator we have is for recommendation relevance. So that's the content that we're seeing the agent produce. We'll be giving the same inputs as we do over here, and this time we're saying to respond with correct if all recommended movies match the requested genre or criteria, and the recommendation should be relevant to the user's request, and it also shouldn't be repetitive. Like, we shouldn't be getting 5 of the same movies returned to us. So we can run both of these. These are just string templates. That's done. And then the next step is to actually run the evaluator. We're going to be doing this using Phoenix Evals and LLM Classify, which runs LLM as a judge. We're going to use GPT-4o Mini to run our LLM as a judge. Above, when we actually generated the traces, we use GPT-4, so we want to be careful to use a different model to evaluate. We also pass in our OpenAI API key here, so we can do LLM as a judge using OpenAI properly. We specify Rails, which ensures that our judge output is either going to be correct or incorrect. We don't get any other labels. Within LLM Classify, I'm also going to specify that I want an explanation provided, and then we'll see what the eval result data frame looks like. So let me run this. So this has finished its run, and we can see we have mostly correct answers for our tool calling order on these 7 examples that we ran. We have one incorrect here, which we'll look at closer later on, and then we also have explanations provided. And for each of these, we have our trace ID right over here. We also get metadata provided over here. And now we're going to do the same exact thing for the relevance eval, using LLM Classify, passing in our appropriate prompt template, using the trace data frame, and providing an explanation. So this one has also now finished its run. We can see really nice performance here with a bunch of correct labels, and we have our explanations provided as well. The final step for trace level evals is actually logging these evals back to the Arize platform so we can see these tagged at the trace level. So I'm going to do that over here. Just to quickly run through what this code is doing, we're taking in those evaluation data frames that we just got over here. So that's our tool eval results and our relevance eval results. And we're grabbing the label and explanation from each and just renaming it to be tool evaluation label, tool evaluation explanation, and then same thing on the recommendation relevance side. And then we're going to combine all of that into one data frame over here. The next step is to take our trace data frame with our trace data and our evaluation data frame and merge them into one. And then we also just take the extra step of renaming our columns. In order to get trace evals to populate properly in the platform, we need to add this prefix over here, trace_eval, in front of our labels and explanations, so we can indicate that this is in fact a trace level eval. And then we grab our root spans, which is the first span in the trace, and log our evaluation to the root span. So that's what's happening over here. And then we define the Arize client, which takes in our space ID and our API key. And then we use log evaluation sync to actually take this data frame that we finally had over here with our evaluations attached to the root spans and log that to our specific project. So if we run this, that's finished, and I'm going to go back to Arize and show you what this looks like. So now I'm back in the platform. I've clicked into one of our traces. This one was the question asking, give me a classic drama from the 90s. Up top, we can see our trace evaluations were logged right here. So for recommendation relevance, we got correct. And for tool call evaluation, we got incorrect. And we can see why. So if we click into this evaluations tab over here, under the traces section, we see both of these evals right over here. And we also ask for an explanation. So over here, we're saying that for the tool evaluation, it was marked as incorrect because the trace output does not show any tool calls being made, which is necessary to fulfill the user's request for a classic drama from the 90s. So as our output, let's see what we got. We just got one classic drama from the 90s is Shawshank Redemption. But what the evaluator expected our agent to do is actually use the movie selectors tool in order to do this. But it seems that because of this type of question of just give me a classic drama, the movie selector tool wasn't used properly in this case, or used at all in this case. So that tells me that I probably need to go refine the prompt or refine the instructions of when to actually use movie selector. So this is something that we grabbed at the trace level. And then for recommendation relevance, we can see that this was marked as correct. And the explanation was the recommendation of Shawshank Redemption is correct. It is a classic drama from the 90s, and it matches the user's request, which is all great. Let's look at another one. So let's grab maybe this one over here. This one was a bit more involved. So if we actually see what the input was, it says, which Batman movie should I watch? And if we look at the evaluations, which are also up here, we get tool evaluation as correct. The tools are called in the correct order. So it first uses the movie selector, then the reviewer, then the preview summarizer, which is pretty much what we're seeing right over here. And for recommendation relevance, we're saying that we get The Dark Knight, Batman Begins, Dark Knight Rises, Batman vs. Superman, all seem correct to me. And yeah, we can click into these even deeper, but if you go into any span within the evaluations tab, you'll see your trace level evals right over there. Hope you took something away from this. Trace level evals are pretty straightforward to run and give you just a nice broad view about how your application is performing. Add a step back that's a bit more broader than span. So hope this is something that you can implement for your use cases, and I will have the notebook that I just ran down below so you can grab those code snippets and put them right into your own applications. Thank you.